In lesson 3, we are going to look at construction technique number 1, which is constructing perpendicular bisectors. So there's an activity at the bottom of page 19 in your workbook. And in this activity, it asks you to mark 5 points that are CD distance away from A. Then it asks you a question about it. So go ahead and pause and work on all 3 of these questions, and then you can come back to the lesson and see how to do it. So when it asks you to mark 5 points that are CD distance away from A, so you've got your compass. So you can open your compass to be the width CD. Okay, and so if you go open to here, now you know that this distance set right here is the same distance as segment CD. So then you can go and just move it to A, and you can draw some different points. So find 5 points that are CD distance away. So that would be one. Then you could move your compass and find another one. You could move your compass and find another one. Wherever, so you can do these 5 points wherever you want. Okay, as long as they are CD distance away from A. So then it says, how could you describe all the points that are CD distance away from A? So what if we were going to do all of them, okay, and not just 5? You could use this compass to just draw all the way around, and then all of those green points are CD distance away from A. Then it asks you to mark 5 points that are CD distance away from B, so I haven't changed my compass, so I'm still CD. And then it just wants you to go ahead and mark 5 points again that are CD distance away from B. So 5 anywhere you want. Then it asks you to describe the set of all of them. So again, that's 5. All of them would be this circle. Okay, so we'd have circle, a circle around it, around A, and a circle around B would give us all the points. So a circle is the set of all points equidistant. So now we see all of the points that are CD distance away from B and CD distance away from A. So then it asks us in a different color, mark the points that are both CD away from, are CD away from both A and B. So these are all the points CD away from A. Which of these points are also CD distance away from B, meaning on the blue circle? Well, that's going to be here and here. So if I had set my compass down, I can see that this point right here is CD distance away from A and CD distance away from B. So that's called the intersection. So that intersection is the only 2 points that are CD distance away from both. All right, so let's see. Why do all points create a circle? Because it's the set of all of the points equidistance away. Did you notice anything about the points that are the same distance? Okay, so they were the intersection of those 2 circles. And then could there be 3 points that are CD away, that are CD away from both of them? So could there be another point that we're not seeing? And that would be no, because this green is all the points. Like we're seeing all the points CD distance away from A. There are no extra points besides these that are that distance away from A or that distance away from B. So we're seeing everything here. So there are 2 and only 2 points. All right, then we did something called the human perpendicular bisector. So this is on page 20 in your notebook. So instead of getting up and moving around the classroom, I just drew 2 points. Okay, so I drew 2 points and I said I wanted people to come up and draw another point that is the same distance from this point A and this point B. Okay, so same distance from A and B. So first group came up, put a point here. Another group came, so then people just kept coming up and setting points down. So we had this one, we had this one, we had somebody put one here. And if you were in class, you could see people kind of taking their fingers on both of these points and moving them simultaneously outward to try to find some other points. We did have a point that was like here. Okay, but kind of they looked like that. So we talked about, again, it needed to be the same distance from both A and B at the same time. So when we look at this one, if we look connecting it to B and we look connecting it to A, does that point seem to be the same distance away from both A and B at the same time? And we decided no, this one is much closer to B. So then we just decided to move it more like here. And what we were starting to notice is that these points look like they're all in a line. So that's called a conjecture. We decided, man, it really looks like all of these points are in a straight line. Okay, it looks like all the points going through are kind of in a straight line. And again, we're just kind of guessing where they are, but that's what we noticed, is that it looks like they're in a straight line. And some people even said, notice the word perpendicular in there and said, looks like they might be the perpendicular bisector of the segment connecting A to B. But so all of those points equidistant from A and B at the same time look like they're happening in a straight line. So just sketch a diagram of that on page 20 in your book. And then, so again, just talked about what are some of the things we noticed and wondered. So notice that they looked like they were in a straight line. Wondered if that was always going to happen, that they would stay in a straight line. And wondered maybe if it actually is the perpendicular bisector, since that's what the activity was kind of called. And so then we wrote a conjecture that we thought that the line was maybe the perpendicular bisector. And a conjecture is just mainly a guess. Okay, so when you make a conjecture, you're just making a guess about what's happening. Doesn't mean that you know that it's true, but just what's a guess from what you're noticing that you're going to end up trying to prove true or false. And it needs to be a guess that makes sense. So based on the picture, just some things that you're noticing. Okay, so what are some things that we were noticing on this? And then actually thinking about, and then making a guess further. So some patterns you're seeing, that kind of thing. And then perpendicular bisector. So the perpendicular bisector goes through the midpoint because it's going to split the line in half. So this right here is the midpoint. And we see, so let me actually make that point bigger so it sticks out. This is in the back of your student workbook. So you can go back to your student workbook and kind of highlight, underline some things. I also changed the definition slightly. So if you like my definition better than the book, you could certainly write that down. But so that's the midpoint. And then it also needs to make a 90-degree angle. Okay, and the midpoint means that these two segments are equidistant. So remember, this point was the same distance from both A and B. That's for midpoint. And then perpendicular means that it hits at a 90-degree angle. Okay, so we've got this right angle in the middle here. So that will get you both perpendicular, because you can have perpendicular lines. You could have a segment being bisected, or you could have both happening together. So in this one, each of these is not a perpendicular bisector together. So let's take a look at why. So in this first one, we've got the midpoint, right? So we've got C is in the middle. So this dotted line is breaking AB up in the middle, but there's no 90-degree angle. Okay, so there's no right angle here. So these ones, this one is just a bisector. Okay, so this line is just a bisector, just splitting AB in half. This one over here only has the 90-degree angle. So these ones only have the 90-degree angle, so no bisector. So these ones are just perpendicular lines. Okay, so lines that are intersecting, that hit at a 90-degree angle would be perpendicular lines. So in 3.3, you can pause the video and try to come up with how you might connect these two ideas here. This one that we used of getting all of the points equidistant, and then remembering that 2 points on the perpendicular, any point on the perpendicular bisector is equidistant from both A and B. Okay, so how could we connect those two ideas to actually construct a perpendicular bisector? So looking here, again, if we know that 2 points on a perpendicular bisector, if I know that anywhere on this line is going to be the same distance to A and B, or that's what we hypothesize, and obviously my drawing isn't great, but if we hypothesize that any point here is going to be equidistant from A to B, that these are going to be equal distances, okay, or that here to here is going to be equal distances, if we could find this point and this point to connect them, we could get that perpendicular bisector. Okay, so if we could find this point and this point, we could get that perpendicular bisector. So if you just open your compass, the width of PQ, you could draw a circle, all the points this far, PQ away from P. Then you could do it again around Q. Then you would have the intersection points up there. So now you would know this point is equidistant from P and Q, and this point is equidistant from P and Q. So if those points are the same distance from P and Q, then they have to be on the perpendicular bisector. So if we connect those 2 points, we would get all the rest of the points that are equidistant. So then you end up with a 90-degree angle here, and these two pieces being congruent. So if you wanted to write down some directions there, so we opened the compass to length PQ, and actually we could probably just write create a circle with center P and radius PQ. And then create a circle with center Q and radius PQ. And then those intersections, you just connect the intersections of P and Q. So of circle P and circle Q. So connect those two intersections. That would be how you end up with a perpendicular bisector. So some other methods that people came up with as they were trying to figure it out. Some people folded their paper. Okay, so folded the paper in half, which obviously only works when you have paper. So we can't just fold the screen in half. Some people tried to guess where it was, which again, we don't want to guess because that's just estimating, not exact. Some people also didn't open all the way to PQ. They just kind of opened over halfway. Also maybe even only drew half circles. So this, if we kept the compass setting the same, this still guarantees a point that's the same distance this far from P and Q, this far from P and Q. So this one would be fine. Still gives you the perpendicular bisector there. So if I had opened this up to full PQ like we did, Okay, let's see if it'll still get us the same thing. So opened to PQ, draw around P, opened to PQ, draw around Q. Okay, and if I extend this a little bit here, notice that it still goes through those two intersections. So we get the exact same line, even if you only open it over just over halfway. All right, then let's look at some of the notation that we've learned so far. So we've got a center point, okay, which is A and B on this diagram. You've got intersection. So intersection is where the figures cross. So if we're talking about the intersection of circle A and circle B, that's going to be these 2 points. If we're talking about the intersection of segment AB with circle B, then we're talking here. So that's where AB intersects circle B. Or if we were saying where AB intersects circle A, that's going to be here. We've got segments. So segments have starting points and stopping points. So CD or AB are ones that are actually labeled out there. Versus a line, you've got the 2 points, but then the line goes through them. So a line goes through them and goes on forever, versus a segment just starts and stops on the endpoints. Points, okay, just any of those dots all around. The circle is the set of all points. Okay, a line is made up of all points. Okay, just a bunch of points. Circle, set of all points equidistant from a point. Okay, so these ones, this is from our warm-up. So these are all CD distance away from B, set of all points CD distance away from A. So circle is the set of all points equidistant from a center. On the circle would be these dots that are on the circumference of the circle or on the line of the circle. Okay, so those are on circle A. These are on circle B. Inside the circle, so inside of this red circle would be kind of all of these points. B, C, D, this point is inside of the circle B. Outside of the circle would be like this, okay, or A would be outside of circle B. Radius just connects center to edge, so there isn't a radius labeled here, but if we labeled this point as E, we could say AE is a radius. If we labeled this point as F, we could say AF is a radius. You could say BG is a radius if we had that labeled, but center to edge for the radius. All right, then let's take a look at this diagram. So just sketch this diagram at the bottom of page 22. So just get that sketch. So just pause the video and sketch that there at the bottom of page 22, and then we're going to discuss some information about it. So in this diagram, we've got congruent segments. Okay, so how do we mark congruent segments? So CD is the perpendicular bisector of AB. So segment AE is congruent to EB. So we mark it with tick marks. And then when you write this down, you'll see it written like this. AE is congruent to EB. So this means congruent. Okay, segment AB, you draw a little picture of the segment above it. EB, equal length, so that just means that their lengths are equal if you measured them. So congruent segments means the picture, same shape, same size. Then if we say length, we just don't have a picture above these, and we just say AE, the length of AE is equal to the length of EB. So this will be actually talking about their measurements. Perpendicular segments here. So we've got AB getting bisected by CD, okay? And that's a perpendicular bisector. So perpendicular lines, remember, meet at 90-degree angles. So the way we would write this out is we would say CD, so segment CD is perpendicular to, so this symbol means perpendicular, to AB. So when you see this, you know that it means that there's a 90-degree angle there. A right angle, okay, just means that, so then that's a right angle. So that just means that the measure of the angle, so the measure of angle, and I'm going to use 3 letters to describe this. So the measure of angle AEC is equal to 90 degrees. Okay, so that's talking about the measure of that angle. A right angle on a diagram, you'll just see this marking here. So you'll see this in the corner. So that's just some notation that you would want to make sure that you knew. And then back to that conjecture of a segment of our perpendicular bisector is that we determined and thought that any point on the perpendicular bisector is going to be equidistant from A and B. So this segment is equal to this segment anywhere on this line. So this segment is going to be equidistant from A as it is from B. So these would be the same. So if you pick any point on that bisector, it's going to be the same distance from A and B. So there's the summary we've done. We did two vocab terms that are back in your glossary. So you should have highlighted those and kind of talked about that. Major thing about conjecture is it's a guess. Perpendicular bisector, we learned the construction for it. So open to a width of your segment, draw a circle around each, that perpendicular bisector, all of the points along the bisector are the same distance from A as they are from B. Also that this is the midpoint, this was split into 2 congruent pieces, and you've got the 90-degree angle there. All right, then the cool down on this one talked about, so can you construct the safest path for you to travel between these 2 lasers? And this is kind of missing a little bit of context because it said that this is a hallway. So you're in a hallway, so you're stuck in this box, and you've got these 2 lasers here shooting lasers. How are you going to stay the safest distance possible away from both? So that means never getting closer to one laser than you are the other. Okay, so trying to go directly through, the middle of them. So not getting closer to laser 2, not getting closer to laser 1. So we want to stay in the middle here. Okay, but we want to guarantee that we're in the middle. So if you were to construct the perpendicular bisector between these 2 lasers, okay, so think of this as a segment, open your compass to each laser, the width of the laser, draw a circle, okay, draw a circle around this one. This is the perpendicular bisector. This will give you the middle of those 2 points and get you the safest path possible through that hallway. So this will keep you the same distance at all times from both lasers. You will never get closer to one than the other. And technically within this room, this is the actual path. So it would just be from you out of the room. So just on that green line, because then you'd be out of the room. All right, so in this video, you learned how to construct perpendicular bisectors, and you also hopefully know and understand what is special about the set of points equidistant from 2 given points. That's the perpendicular bisector. Okay, so special about the set of points equidistant from 2 given points creates a perpendicular bisector.